A big hello to all the champs and welcome to ESP8266 video number 4. I hope you are all aware and all the previous lectures are completed and you have basically configured your ESP8266 and Arduino to work in serial with each other. So let's get quickly started with video number 4, and before I get started, let me tell you some prerequisites. Alright, so today what we are going to do something very different today. We are going to write directly to ESP8266. So we will write directly to ESP8266, right? And believe me, it took me a while. It took me almost 12 hours to see the fastest possible way to communicate, because ESP is used as a microcontroller itself, but yeah, it has limitations as it has only one GPIO pin. So we have to look for other ways so that we can interact between ESP8266 and Arduino. So today, after working for almost 12 hours, I found some solution, right? Because I kept on trying things one way or the other, right? Because where there's a will, there's a way. So I found a way, so I'll share my way with you guys. But yeah, that way is that we still have to directly write to ESP8266 and use some libraries, right? And for that you need to enable programming mode to your ESP8266 device. And how do we do that? So you're already aware of that. So we'll not be handling or will not be doing 80 commands anymore, right? So we'll be programming the microcontroller of ESP8266 Wi-Fi controller, right? And for that, what you have to do, connect the TX to the TX of the Arduino, RX to the RX of the Arduino, you know that, and GND of the ESP to GND, right? And GPIO 0 has to be grounded because it enables the programming mode, as you guys know. Plus 3.3 is going to be connected to plus 3.3 volts, and please, this process requires the regulator, so you will connect it to right, LM1117 PR, which is the power regulator. So this operation is already known. Now you guys will do it like a pro because you're already familiar with this operation, right? So LM1117, right? So now when everything is connected, connect the reset through the button, because this is what enables you to program ESP8266. Connect the reset button to plus 3.3 volt output of the LM1117, or you can connect it directly to the output, but yeah, it is better to connect it to the same output of LM1117, right? So this is going to enable the programming mode. And now the second thing what you got to do is deactivate the ATmega chip of your Arduino device, right? Insert a jumper wire in the reset pin and connect it with GND. So reset pin of, I have written it, RX to the RX of the Arduino, TX to the TX of the Arduino. So GND to GND, GPIO 0 to GND, enabling the programming mode. CHPD or EN to the to plus 3.3 volts. Again, CHPD or EN will always be connected to plus 3.3 volt, and 3.3 volt to the 3.3 volt of Arduino or LM1117, and reset to the plus 3.3 volts. In order to enable serial communication ESP01, we need to disable the ATmega chip of the Arduino to bypass the communication to ESP. Now we need to bypass the communication. We don't want to communicate because we have to program the microcontroller of ESP. So we need to bypass. So for that we will connect the reset pin of the Arduino to the reset to GND, right? So once this is done, right, so what we are going to do, we are going to just test whether everything is fine or not. For that you open Arduino, and the second thing that you have to do is, it's very important for this process that you go to tools, and then go to the boards and go to boards manager, right? Once you go to boards manager, what you need to do is you need to it will take a while downloading the platform. It's going to take 2 or 3 minutes. Please be patient while this process is complete. So as soon as the process is completed, then and only then you'll be able to search for ESP8266 library. Once ESP82 library is ready, right, what you got to do is, I'll tell you, you have to search for ESP8266, or what you can do directly, file, you can go directly to files. You can see the files menu here. So it's the menu bar, so you can directly click on the files menu. Okay, let me see that if I could connect, yeah, I can directly go to files menu. No, it's not able to click. Let me wait for a second unless it completes the operation. Yeah, now you can see I'll go to the files menu, go to preferences. After you go to preferences, now you can see this right here. So this is what is required. I'll just put it in bold right here so that you guys can copy this. Alright, so this is the URL that we need to put in so that our ESP8266, now you can see, right, so this is the URL that you need to put here. If you have already downloaded, that's quite okay. Now additional boards managers URL, so this is the URL that you have to put, right, and what you have to do here in order to skip the download check, right, or in order to skip the startup updations, right. So check for updates on startup, you need to uncheck this. So check for updates on startup, you uncheck this, right. After you uncheck this, click OK, right. Okay, and then go to tools, you'll go to boards and boards manager, and you'll have to do the same thing again. So I repeat, right, so this is very important. Why? Because we know that we are having, like, if you are having Arduino Uno, you have to download the board Arduino Uno and all the specifics and all the ingredients and files and libraries related to related to Arduino Uno. And some of you have Arduino Nano, you still have to download it if it's not there. For example, if you get Arduino Mega tomorrow, so you'll still have to download, or any other device, like you get Node MCU tomorrow, you still have to download it, right, from the boards manager. And your Arduino IDE has to know the board that you are dealing with or programming, right, so that it follows the regular pattern. All right, so let's get started now. Okay, so now you will search for ESP8266. Now you can see right here, right, so there are many versions. So I've installed the latest. You'll install 2.5.1, 2.5.0. so you can see all the versions are available. So mine is already installed 2.5.2. Yeah, so I have installed 2.5.2, which is not available here, I don't know. So it's already installed 2.5.2, right, because it's not going to show it here, it's going to show earlier version. So now click on install and wait till the time the board is installed. In case if you are not able to find it, you need to upgrade your Arduino. I'm using 1.8.1.0. You can see the version that I'm using here. In case if you're not able to see this or search ESP8266 by ESP8266 communities, so then you'll have to upgrade your Arduino. And now I presume that everything is done, right? So after having done this, right, so once you do everything all right, and follow all the steps, and now Arduino is bypassed, programming mode is enabled to ESP8266, and every single thing is done. So now what we can do, we can directly go and start programming the ESP8266 device, right? But for that, we have to go to boards and select the board right here. Go down and you can see it here, generic ESP8266 module, right? Do not go for 8285, it's generic 8266 module, and select this. After selecting, go to COM port and see that the specific port is connected. So now then, if everything is done and if everything is fine, alright, what are we going to do? The first test is going to be blink test. So now what I do, I will say, I'll go to examples, right, and after going to examples, I can go to ESP8266, you can see here, and there's a test blink. Now this is the blink program. So I'll download this blink program. All right, so let me upload it directly. Now since Arduino is bypassed, right, and the programming mode of ESP8266 is on, because GPIO 0 is already connected with the GND, and TX and RX communication is on, we should be able to directly write, instead of writing to the memory of Arduino, we'll be writing to the microcontroller, which is as that of ESP8266 device. So I'll say upload. And now you can see the download process will start. So we'll be downloading it. Now you can see the process right here. It's not getting connected, right? And now once this process right here, you can see this. Okay, once this starts, you hit the reset button of the Arduino, reset button of the ESP8266, which is connected to plus. Now as soon you hit the reset button, the communication should immediately start. I repeat, you have to hit. And even if it fails, right, you can directly do it again as many times as you want, right? But yeah, it should enable the communication. right? Okay, now then I hit this, yeah, I hit the reset button. Now you can see the upload process has started, right? Now you can see it here. If I scroll it down, you can see, oh my god, I just disconnected something, right? Okay, let me do it again. I disconnected it, I don't know, purposefully. Let me increase it and show it to you. Now, as soon as this process starts here, the lines will start coming here, right? So what you got to do is searching for ESP device. It's not able to find ESP device. Alright, so when it does, you can hit the, okay, now it has started, right? You can see it here. Now as soon as it starts, hit the reset button and it is going to upload. Now you can see the upload process has started, right? So if you can scroll it down, you can see 25, 33, 41, right, 50. Now it's writing directly to ESP8266, right? So we're writing directly to 8266 ESP. Now, so it's going to take a while, but you keep on scrolling and check 100%, right? And it's still uploading, and now you can see here, uploading is done. Leaving hard resetting via RTS pin, and uploading is done. So once uploading is done, you should be able to see. Now reset and restart your ESP device. Disconnect GPIO 0. It's just the test, right? And keep everything connected, only reset GPIO 0. You should be able to see the blue light blink. Now you can see the blink test is successful, right? You should be able to see light blinking, right, after 1 second. What is happening here? We're delaying for 1 second and doing low and high, right? Okay, after it's blinking, connect the GPIO 0 back. Now we have to program it again, right? After the blink test is done, connect the GPIO 0 back. Now we are going to write our own program, right? So now we shall start writing our own program. So I'll close this blink. I don't require this blink, okay? Alright, so blink test is done, right? I'll directly go to my file. I'll open a new file and now start programming. The first thing that I'll be doing, as soon as you install a new board, so it is going to give you few libraries. We'll say hash include, alright, so you can say hash include ESP8266, right, WIFI.h. Now W is capital and F is capital, it's case sensitive. Hash include ESP8266 Wi-Fi.h. That's the first file we include. Second file, because we have to make it as a web server. I'll write second time hash include, third time hash include, and let me keep them ready. Okay, so the second file that you're going to include is Wi-Fi. I repeat, it's going to be Wi-Fi. W is capital and F is capital, CLIENT. W is capital, F is capital, C is capital. The moment you write it correct, color changes. Wi-Fi client.h. Right? So now Wi-Fi client.h is here. And second thing, you have to handle the web server. So I'll say ESP, capital ESP. I repeat, it's full capital here. ESP is capital, W is capital, F is capital. W is capital, F is capital, C is capital, and here ESP is again capital, 8266, right? And then we include the third file as web server.h. So since I've included all three files, right, and now you can go, if you do not have, you can directly go to, if any one of this is missing, right? So they are going to change the color only when you select the proper board. For example, if I select, let's say I am going to select Arduino Nano. Once I select Arduino Nano, you can clearly see these files are not available here. The color is black. So they are not available for Arduino Nano. So they are going to be available for the board, which is ESP8266. The moment I change ESP8266, and you can see there, we are able to find them as well. And rest of the programming is going to be same, right? But yeah, what we are going to do here, so I'll create a pointer. I'll say constant char. So let it be a pointer. And I'll define my SSID. It's going to be your SSID. And if you want to make it as access point, you can still make it as access point, right? But yeah, I'm going with station mode because we have to, after this tutorial, we have to get connected with internet and communicate with ESP device, and the ESP device will communicate with Arduino right from internet. And then we'll also see analog signals and how do we pass analog as well, analog input and output both. So I'll say constant char password password is equivalent to your password. My password is password @ 123. So now then it's ready. Now start your web server on port number 80. So I'll call this ESP8266 web server, and I'll call this server, and I'll start it on port number 80. So that's the second thing that I'm doing here. Alright, so now we know that we have void setup is the first thing that I'm going to have, and I'll make a bit of haste because it's going to be then longer video then. Alright, so I'll go with void loop. So these are two different things that we already know what both of them do, right? And quickly I'll do here serial.begin at 115200, the baud rate. Okay, and I will also call Wi-Fi, which is here. So I'll say Wi-Fi, F is capital, dot begin. It's already defined in the Wi-Fi client library. Okay, so I'll say Wi-Fi dot begin, right? And I'm going to begin Wi-Fi with SSID and password. It takes two parameters, right? Wi-Fi dot begin takes two parameters. One is SSID and another is password. So it's already set. So now I need to get connected to this, right? So for that I can do this. Let's say I want to go to new line. I'll say serial.println just to go to next line. Nothing. I don't have to print anything. I want to start from the next line. So this is what you already know. Now, unless I'm connected to this Wi-Fi, I have to hold the setup, right? I don't have to come out of the setup and go to loop without having connected or without having been connected to my Wi-Fi or any hotspot that we have. So without connecting to the hotspot device, so I will not go outside the setup, and I'll have to keep it busy inside the setup. So I'll keep my setup busy. I'll say while Wi-Fi dot status is not equivalent to so the status gives that message Wi-Fi, that is wireless LAN WL connected. It's capital. This is already defined in Wi-Fi, right? So whenever you say Wi-Fi dot begin, it returns WL connected or disconnected. So while it is getting connected, right, what you got to do is the following. And now what we are going to do here is we'll say delay 500 microseconds. Okay, after delaying for 500 microseconds, I will say serial dot print, just print dot. All right, so that dot, so unless we are connecting, the serial monitor is showing us dots, means we are getting connected, we are getting connected, we are getting connected. You can blink the LED here as well, as I have shown you in the previous video, right? You can have that LED blink as well. And now now you will only go to this line. Whatever you write here will be available only when you come out of the loop. You'll come out of the loop as soon as you're connected, otherwise you're not connected. Right, so I will say now, after then you're connected, I will say serial.println. Again, I'll go to the next line and I will say serial.print. Right, I'll say COW connected to, I want to see the device that I am connected to. So I will say serial.print, right, I am connected to Wi-Fi. Alright, so wireless fidelity is the full form of Wi-Fi, it's string. And again, I will just copy this. And the second line, I am going to print the IP address. So now the address that I'm connected to, right? So IP address is going to be, now I'll call this function again, Wi-Fi, and I will say Wi-Fi dot get, no, it's not get, Wi-Fi dot local. I suppose IP is capital, yeah, local IP. So I want to get the local IP and display it, serial.print. So we will be getting connected to the total Wi-Fi. So now I suppose it's good enough to give it a try and get it done. So this is the first process, and the first process has been achieved quite successfully. So we need to give it a try and see whether it works or it does not work. Right, I suppose it's good. Right, so we should give it a try. So let's carry on. Now upload. Now while you start uploading, right? Because the programming mode is turned on, Arduino is bypassed, our XTX pins are connected, every single thing is working fine. And now click upload. Okay, we have an error right here. Let me see that first. If Wi-Fi.status is not equivalent to W, okay, and what is the error? Okay, we did not terminate it here, so let me check for the errors first before I upload. Alright, so I'll have to compile and then upload. Checking for errors, so let it check for errors before I upload it. Alright, we still have some errors. You can see that I forget terminators. I am a bad terminator. I'm not a terminator, I'm a starter, right? Okay, it reminds me of the Terminator movie maybe. Okay. Come on, you're making too much of time. So by the time you are connected, why don't I make a file for you guys, right? So I'll make a file for you guys. And let's get quickly started, and then I'll document your file as well. Do not worry. Documentation will also come. Okay, now it started uploading. Now I'll have to hit the reset button before it gets uploaded. Okay. Now then, I have hit the reset button. The upload process has started. Now you can see clearly here 30, right? So you can scroll manually 30, 53, 61, 69, 76, 84, 92 and 100, I suppose. Yeah, hard resetting via RTS pin. Yeah, right. So we have now done. Upload process is complete. Now for a while, just to check, I repeat, you need to be attentive here. Just to check, disconnect the GPIO 0 pin, right? Disconnect the GPIO 0 pin from GND and just give it a try, right? Restart your Arduino. Do not bypass, do not disconnect the bypass, right? You just disconnect, because you have to do communication with, right? Yes, ESP8266. You're communicating with ESP8266. In that case, you don't have to disconnect anything else, but only GPIO 0. And while RST and GND of the Arduino will remain connected. I repeat, RST and GND of the Arduino will remain connected. So I'll hit reset and see what happens. Now you can see dot dot. It's coming because of the serial dot pin dot 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 dot. Yeah, now we are connected. Connected to Wi-Fi IP address 192.168.137.20. So we have not started the server yet. That means the first process is successful, and we have successfully completed the first process. Hip hip hooray. Right, and then this is it. So loop is not going to have anything, right? I suppose, yeah, loop is not going to have anything. So I'll just disconnect this. I'll keep the loop as it is, right? Right, and I will say only disconnect the GPIO 0 and test. I mean, it's very it's always recommended to test each and every step, rather than writing everything and then don't you don't know, or you never know how many errors we do face after we write all the lines, right? So we'll have to be sure of getting as less errors as we can, right? So only disconnect the GPIO 0 and test after, right? Disconnecting the USB and connecting it back, right? So connect and disconnect, and then and only then you'll be able to see this, right? You'll see the dot 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 dot, right? Or not only dot dot dot, you should be able to get an IP address. So this dot 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 will come unless you're connected. If you're not getting connected, this dot 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 will keep on coming for the entire life, right? So the entire lifetime of the ESP, or till the time ESP8266 is started. Now, since the test is successful, after the test, so I'm guiding you through, right? Connect GPIO 0 back to GND and enable the programming mode of your, right. So now you have enabled the programming mode of your ESP device. Now let's do the remaining things, right. So far we are done and we do not have any problem and test is complete. Now we have to send HTML, right. So let me go and say send HTML page back to, or you can say set or not send, I'll say set an HTML page, right. So I'm setting an HTML page and I'll say constant, right, char, and I call this as main page. So I'm going to declare it as an char array, and let's call this as progra, or we can say prog, that is program memory, progmem. So now what is this program memory? Okay, someone is calling me. Alright, wait a second, I'll be back, just 2 minutes. Alright, then I'm back. So now what we are going to do here, I told you we were discussing about, or we were very, we can say very worried about the communication process, as there was a huge lag in communication, whether it was a post request or a get request. We were not able to manage that lag, and it's because of that lag we could not even think of an internet. Had it been internet, imagine the lag using internet, right? And I repeat here, ESP is not meant for communication with Arduino. This is what we are doing, because our field, what I think my students should also do is research and development. Do not stick or get completely attached to books and say that everything that we read from books is right and that is the only thing that has to be achieved. No, you write your own books. That is why we decided to open an R&D division where we'll give all the equipment free to students for research and development. Yeah, that's a long process. Still, we'll have to see the compatible and the passionate students, or those students who at least have good amount of brains to experiment, right? And those students who say, okay, sir has shown us and that's the final thing, or I am showing you something and this is it, what you have to take forward, and the world ends here. So the class is not the end of the world. So you'll have to do a lot of research and a lot of practice, right? So that's what. Now, what is this program memory? Now, what I am enforcing ESP8266 here. I repeat, I want this page to be directly loaded to the RAM. I don't want my RAM to read the flash memory. Reading the flash memory, RAM reading the flash memory, and flash memory responding back will take good amount of time. So I spent good amount of time reading this as ESP8266 RAM with program. So save ESP8266 RAM with program, right? So it has every single thing, right? So you can even find so you can say program data, right? You can see here. So it has good code. You can even see, right? How do we define it? So I have just taken the definition. You don't have to go through it. I have taken this definition and I will share the definition with you. All right, the first thing that is going to be, I have just shared it here. All right, so I am going to mark this black and you will see that ProgMem is an Arduino AVR feature that has been ported to ESP8266 to ensure compatibility with existing Arduino libraries as well as saving RAM. On the ESP8266, declaring a string such as constant XYZ, this is a string, will place the string in a RAM, not flash. It is possible to place a string into flash and then load it into the RAM when it is needed. On an 8-bit AVR processor, this is very simple. On a 32-bit ESP8266, there are conditions that must met before that must be met to read back from the flash. So it takes a long or it takes a while to read back from the flash. So that is why we are writing directly to the memory here. All right, so this goes directly to the memory and the memory is allocated directly. That's why I use this main page as ProgMem. I declare it now. We have the reference. The reference of this ProgMem, whatever we make, is going to be in this main page variable, which is of type pointer here, or which is of type char array. So it's of type char array. Now you can see once I say ProgMem, this is the process where we say we're writing the raw string, right? And I'll say is equivalent to 5 times equivalent to. Now whatever goes in here, till here, right? We'll go directly to the RAM. And now this is the process wherein you can directly write. Now this is the start of the string, and now you go, it is the end. 1 2 3 4 5. So now, and in between this and this, I repeat, in between this and this, you can write anything that you want to write. Now this is where we have to write our HTML code, and I want it to be directly in the RAM. I repeat, the instance will be main page of whatever you're writing directly to the memory of ESP8266, because ESP8266 has a 32-bit microcontroller or microprocessor installed, and you're writing directly to the memory rather than to the flash memory. You're writing to RAM, not to ROM, right? Or sorry, not to ROM or not to flash memory, right? Because once you upload the program here, we uploaded every single thing in here, right? Where is this stored? This is stored in the flash memory, and any variable that you declare at runtime will get saved or it will get allocated in the RAM. So we are writing it directly to the RAM so that it is more faster. The HTML process is more faster for us, right? So that's why now you can directly go with HTML5. So I'll say doc. Now you can see the luxury here. I'll say doc type HTML, and you can see start an HTML tag, you finish an HTML. That's why I said that it took me a while, or behind this program is lot of research. And even after developing this program, I faced lot many problems that I had to rectify first before recording the class. That's why it's a bit late, right? Because I never knew it's going to take 12 hours or 8 hours or 9 hours. So I thought it's going to be 1 hour job. But yeah, as promised that we are going to get rid of the lag. So I had to fulfill my promise, right? And here we go. Now this is the start of the HTML and this is the end of the HTML. Now we can say inside HTML we have the body tag, as you know, and this is, now we are indenting the code as well. Not only we are writing, you can say we are writing it directly, because this is a raw string which is directly going to the program memory, right? And now what we are going to do this, if you want to set the title, you can set the title in the head tag. If you don't want the head tag, it's obviously fine if you don't want. In case I'm not going for head tag because it's going to be the waste of memory, so I'm going for only body tag. So I'll say h2 and h2 close, and what I will say IoT home, right? And I'll say IoT my home. So this is what is going to be used for my home. I'll say h4 and close h4 here. So I'll say operations and status, both operations and status, right? Okay, fine. Then it's not going to be, it's still taken status as a keyword, but yeah, it's fine that because everything is will be taken as a raw string, so we don't need to worry about. Now let's go directly. Form action is equivalent to, right? So I will give my form action to process. That means whenever I submit my form, everything that is inside the form will go to this URL process. For example, if I load my website, let's say I load my website 192 or something, and then when I load my website, right, all the form, right, whatever is inside the form will be sent to this URL, which is going to be process, or you can call it anything, process, right? You can see this is going to be the URL, right? So now we are sending everything to process, or we can say process form as well, whatever you want to say, right? So this is the start of the form and this is the end of the form, as you guys are already aware of. Let me design a table for you. Now we have a table with cell spacing 5 pixels, and let me give cell padding of 5 pixels, right? Okay, now I'll close the table and I will say table row and table row, fine, and table row closes, and table row has a table division and table division closes. So let me see the time. Oh, we already are at 34. It's going to take 1 hour, I suppose. Okay, I'll do it quick, right? So what I do here, I will say tr. So let's say it's going to be my bedroom, light bedroom light, right, 1, or we can say front light 1, right? And another TD, I'm going to have it here, and this is going to be input, just to submit the request. Input type is equivalent to submit. So input type is equivalent to submit, and I'll give it a value. Value is equivalent to 8, and I'll give it name is equivalent to process. Right? So it is going to be process. Fine. Always remember that we have to target this process name now. It's a self-closing tag. So to do it fast, I'll just copy paste it. Copy paste, copy paste, copy paste, copy paste. Okay, fine. We have enough. Okay, now we have front light 2, and it is going to be pin number 9, and then we have pin number 10. So it is going to be bedroom rear, or we can say backlight, or we can say rear light 1. It is rear light 1, and let it be 10, right? And the rear light 1 is going to be rear light 2. It is going to be 11, and bedroom bed light, or we can say bed night light, is going to be 12, right? So we have 12, 11, and every single thing is right here. So it is going to be sorry, our form. So now then the form is ready. I'll quickly save this form, right, and it is going to be saved directly to the memory. No need to worry about the space now. Right, now we need to handle this, right? So we need to handle each and everything right here. Alright, so now since we are connected, and what we get to do is now, right, okay, now we have to make some functions. Let's quickly make some functions. Number 1 function is going to be void. Let's call this handle, right? And let's say handle root. So what is going to happen when you load the website for the first time, right? And this is going to be void handle a request. What is going to happen when you request for any light turn on or turn off, right? Sorry. Now handle root, I will make a string. So I'll say string s is equivalent to, and we just made this main page, so I'm going to send this main page here. Handle root will take main page, and I will say server dot send. 200 means send OK, or 404 not found. 200 is always OK, right? You're sending the response code first as it's OK, and then you say text slash HTML. You're sending an HTML file, and what is going inside HTML here? S, right? So you're sending this S. Now what is in S? The complete form, nothing else but the form, right? And that's it. And now what is going to happen when you load the request? You know, we still have to send this command to Arduino, right? So that's going to be a tough job. So let us say now string, I'll say LED number is equivalent to server dot argument. Now what is the argument? Now you can say as soon as you click on submit button, right? So the argument is going to be processed. So it is going to be something like this. If the IP address, what was the earlier IP address that we called? Yeah. Now you can see 192.168.137.210. So now you'll have to type it like this. Okay, I'll show you. I'll show it here. Okay. So I will write it down. http://192 and IP address, and then you are going to get question mark. The argument is process, and if you hit this button, you are going to get 8. So process is equal to 8. If you hit this button, you are going to get process is equal to 9. So now what do you target? The argument that you have to target, or the parameter that you have to target, is 9. So that's what I say here, that handle request is going to take an argument from the server, and the argument is process, right? So this is the argument that we are going to take. What do you do with that process, right? Yeah, I'll tell you what do I do. Nothing. Serial dot write. Once I do serial dot write, I'm going to catch this serial dot write inside Arduino, right? So look, this is the trick that I was working with, but I had to format 300 times while trying different things, how to write to serial, whether we have to use serial library or not, and different things. I had to format it, I don't know how many times, but yeah, finally this is the final thing. You don't need to format anything. You'll get going inshallah at the first go, right? So serial dot write. So now what are you trying to do? What is this LED number? Whatever the process is going to give you. Process is going to give you either 8, because you go to process form. This is basically the handle. It is going to give you either 8, 9, 10 or any pin, right? But yeah, still we have to do many things before we get started. Okay, now process is going to give you the LED number, and you are writing. Serial dot write is sufficient for you. And what you are doing, you are giving back the same main page, because you are still giving the main page here, because you have to turn all the lights, and then you have to get the response back, and many different things. Now let me go to server setup, and now once this is done, what I do, I will turn on the server here, right? Once you get an IP address, now you've got an IP address. So once the IP address is given, what you got to do? Server, because you already started a server on port 80, and you say I am going to listen to root, which is slash. Directly if I type the IP address, this is going to do. And when you go directly to this address, which is slash 192, you don't type anything. 192.168.131.137.210. Where are you going to start it? You are starting it. You are starting the server using. Let me show you. Let me. Where is it? You are starting the server using port number 80 directly, right? So that means you will go to the root directly. So now that's what I say. When server is on and root is being accessed, what do? I call this function handle root. As simple as anything. You don't have to call it here, right? It does not take parentheses. It's a delegate. All right. So you call the function whenever root is typed. Call the function without parentheses, a delegate. So I'll make you understand what delegate is some other time. But yeah, you have to call this function here. Whenever root is accessed, you're calling this function, right? And what happens if? What will happen? Right? For example, form action is given. So for example, what is the form action? Okay, the form action is process form. What will happen if now the action is not root but it is process form? As simple as anything. I call handle request. That's it. Or I'll say handle form, or whatever you call it. So I'll say handle request. The thing is done. Absolutely no problem. Each and everything is achieved. And then I say when everything is done, what you got to do? Server dot begin. Now if you don't want it to be station mode, if you want it to be IP, so you can say soft AP, right? Or I don't know, it's soft AP IP, I don't know, maybe that. So I'll say soft AP, yeah, soft AP. So you can say server dot soft AP. You can do that. But since we are not going to create an access point, right? So I'll say server.begin. It is going to turn on the station mode, and your server is going to get connected with the SSID that you have typed here, which is this SSID and password. Why? And you are going to start server on port number 80, because you already said that Wi-Fi is going to begin with this SSID and password. No, sorry, you don't have to type AP. There you have to type it here. Right, instead of getting connected and getting used as a station mode, you can directly use your ESP device as an access point. You can type soft AP, right? So now you will be using your device as an access point, not here, right, but here, right? Okay, now since we are not using that, so we'll say server.begin. Now server.begin, right, and I'll say serial.print. Now everything is fine. You will say HTTP server started. What would you say? HTTP server started, right? And then what you got to do is call handle client. That's what loop is going to look for any new client requests, right? So you're going to always look for client requests, right, inside this loop, right? So that's it. What else is there? Do we have anything else which is pending? Please tell me. So let me take a look at each and everything. Oh, I suppose everything is done. Okay, so now I'll go to this, I'll say HANDLE, handle, CLIENT, client, and that's it, right? Give me a second, I'll be back. All right, so now I suppose everything is fine, right? So we should get started and we should upload it and start working with this as soon as possible, right? So should we get started then? Okay, sorry, it's not handle client. Basically, you have to call it. It is server.handle client, right? It's server.handle client. So loop is going to run 24/7, and every time loop runs, you are going to check 200 times per millisecond that any client request may not come, right? So even if any request comes, handle client, right? Handle client is going to work on server port number 80, which is giving you an IP address, right? And now you request for an IP address, right? And when you request for the IP address, you directly go to root and you get handle root function being called, and handle root is going to give you the main page. And if in case you are having this process form, right, if the request is as that of process form, which will happen only when you click the submit button of this form right here, right? So in that case, what is going to happen, you are going to call a different function, which is this handle request function, and it's going to take argument, which is process, and take it as an LED number, and serial.write LED number, and server.send again the same main page, right? I suppose it is done. Let me turn on the GPIO, connect the GPIO 0 back to the programming mode. Okay, we have an error, LED number, no matching function call, hardware serial write. Why am I doing serial.write? It's serial.print, not serial.write. All right, so now it started. Let us wait. Okay, now press the reset button and see the magic happen, and be witness to the magic that will happen. Right, so let me scroll it through so that you can see the upload process. 53. Yeah, it requires good amount of patience, isn't it? Since I've been very patient, I don't know, from maybe 8-9 hours, so I'm still recording it. Yeah, upload is completed and we have successfully uploaded it. Now what you got to do is, the first thing that you have to do, connect GPIO 0, disconnect Arduino and connect it back and wait. Only disconnect GPIO 0 and see the request, or maybe the process. Let's wait for the process and see what is going to happen here. All right, is anything happening? Yeah, nothing is happening. I don't know why. Let me restart the device. Yeah, okay, now it has come. Right, so we are getting Wi-Fi IP address is this, and HTTP server started. Why am I using this? I should not use this. Okay. So let me call this here print. Okay, so let me wait for a second here. So I'll say print ln, right, and print ln here, and also use print ln so that I can see this using the next line. Let me upload it again. Connect GPIO 0 back to GND to turn on the programming mode, and as soon as the programming mode is on, you'll start uploading, right? And the moment you can see these dot coming, hit the reset button, and now the program will start uploading. Right, so now I have hit the flash button. All right, reset button is hit. Now upload process has started. All right, so you'll get upload done. Alright, 100% and upload is done. Immediately disconnect the GPIO 0, reset the device, and see. Now I wanted everything to come, underneath. Yeah, now you can see connected to Wi-Fi, IP address is given, server has started. So now let me go and try. I'm very excited for this. So let me go and try this URL and see what I get. Now see, flash. It has come like anything. Right now I say 8. Open the serial monitor. So I want to see that input in serial monitor. Serial monitor, we're getting 8, 9, 10, 11, 12, 12, 11. Now see how fast it is. Now you can see. See how fast are we loading it. See how fast are you loading it. Now here we are done. Alright. You can see how fast it's happening. See. Right. So now we can think of getting connected with internet. Otherwise with that lag, imagine with the lag that we used to get in the previous classes. But yeah, since we know each and everything, we have dissected this ESP8266. We know all the processes right now. Now the final process is going to be, we are doing serial.print. We are not doing anything, but because ESP8266 has no pins that, no, it does not have. How many pins are we controlling? Does it have 1, 2, 3, 1, 2, 3, 4, 5 GPIO pins? No, it does not have. So we'll not be able to control 5 pins here. That's why we are doing serial.out. Serial.print. So now we are getting this on serial monitor. Now our job is disconnect GPIO 0 forever. After disconnecting GPIO 0 forever, disconnect the reset of the Arduino. I repeat, disconnect the reset of the Arduino button, right, and connect all the LEDs now, right? You have to connect how many LEDs? 5 LEDs. 8, 9, 10, 11, 12, right? So connect all. So let me connect mine. I'll take, mine are already connected, but only 2 are yet to be connected. So I'm connecting mine as well. Now then, I have all the LEDs connected. What I will do now, right? Okay, now all the LEDs are connected. Take RX and TX pin to 2 and to 3 pin, all right? Now TX will go to pin number 2 of Arduino, TX of ESP8266 will go to pin number 2 of Arduino, and RX will go to pin number 3. So far we are done here, so we don't have to do anything. But yeah, now you have disconnected every single thing. Now let me go back and change my board. Back to, I have Arduino Nano here, you'll change to yours, which is Arduino Uno, right? So now I have changed the board, right? And I will open new file now, right? And now I'll open the window, serial monitor. I'll say clear output, right? And now what I do here, nothing, it's all done. I'll say hash include. The first thing that I have to include is software serial serial.h, because I have to get the serial.out that we are doing. Serial.out we are doing at ESP8266, right? So serial.ESP8266 is doing serial.print, right? So ESP8266 serial.print has to be captured here, right, via pin number 2 and pin number 3. So hash include serial, now we'll say software serial ESP is going to be connected with pin 2 and pin 3, which is again RX and TX, right? So I write it down here, RX of Arduino, or we can say TX of ESP2, right? So as I said, TX is going to be connected to pin 2 of Arduino, RX of ESP2, pin 3 of Arduino, right? So once this is done and once this is achieved, now what you got to do is, let me do it quickly. So I'll say void setup and void loop, and this is what I have to do. I'll quickly go to void setup and I'll say esp.begin communication on 115200 because we have to receive what ESP is sending us, right? And I will say serial.begin also. So serial.begin communication has also happened at 115200, and I'll turn all the LEDs mode as output. So I'll say for int I equals 0, right? I is less than or equivalent to, how many pins do we have? Not 0, 8. We are starting with pin number 8 and we are going till pin number 13. Is that so? Let me see that. Yeah, 8, 9, 10, 11, 12. No, pin number 12. So I will say use all the pins and set pin mode of all the pins which are I pins to output. Also do one thing, digital write all the pins from 8 to 12 in a loop as low initially. So this part is done. My setup is ready. Now I'll go to while loop. I'll say if pin number 2 and pin number 3 communication, which is esp.isavaila, if that is available. Now you got to do this. Take it. I'll say int LED pin is equal to esp.read string and convert it to int. Convert it to int because digital write will not take string, and do digital write of LED pin. Do digital write of LED pin as not digital read of LED pin. Do the opposite because I have to toggle it, right? So and do serial dot print. I want to print it on my serial as well, LED PIN. So now that's it. Our job is done. Upload it to Arduino now. I know I keep on getting these errors. So include hash, include INCLUDE, my spelling mistake. Hash include software serial.h void setup. What is problem? Void setup expected terminator here. What am I doing here? I'll say RX and TX. Okay, let me try uploading it to Arduino again. If we have no errors, we're still getting errors for int I equals 8, I is less than or equal to 12. Look, I am rushing, right? I plus. Okay, fine. Now everything is working fine. Let me tell you, by the time it uploads, you are getting connected because you are doing serial.print inside ESP8266, and here you are catching that whatever you are doing there, whatever serial.print happens there, you're catching it here using pin number 2 and pin number 3, right? And then you're starting communication with ESP8266, and you say whenever that communication is available, right, read the string and write it to my serial monitor, also toggle my LED. So now let me go to the serial monitor. Okay, it's not available. Why? Serial. Okay, it's still uploading. I don't know what happened. No, error. Why? So let me say Arduino Nano is selected. Yeah, I have selected wrong bootloader. Fine. Let me try it again. Let me connect and disconnect again and try back. What time is it? It's already been 1 hour. My God. How do you upload it? Done uploading. Go back to serial monitor, right, and check what is happening with your ESP device. Reset your ESP device and see whether you are able to communicate. Yeah, we are getting 0, nothing. Okay, fine. So let us read it from here. Go back, get connected. You are connected. Now if I press, let me get the serial monitor here. All right, so if I press 8, I am getting, what do I get? Yeah, I don't know what is happening here. Yeah, I'm getting 8. So let me just decrease the size. If I type 9, I should get 9. If I type 10, I should get 10. Nothing is happening. I suppose something is wrong here. Maybe the pin configuration. or anything like that. So let me see it again. ESP software serial, ESP.begin 115200 and serial.begin 115200 for it I is equal to I is less than 12i plus plus pin node is going to be as output, and it is going to be as low if ESP dot is available. LEDP is going to take integer digital write and digital read of serial dot print the LED pin, right? So there's no problem at all. Why isn't this coming? Right? Okay, let me try it once again. Let me see the code of that. So we are doing serial.print here. Okay, serial.print LED number. We are doing this serial dot. We should be able to grab it. I don't know. Yeah, we should be able to get it. Let me hit 12. Yeah, we are getting, I don't know, 11, 10, 9, 8. Yeah, LED is also lighting up. Sorry, it might have taken a bit. Yeah, so now you can see, you can hit all 8 and 9. Hit immediately 8 and 9 on. Alright, so you can do that. 8 on, 9 on, 8 off, 9 off, on. Right, so no lag. You can see that there is no lag at all. Right, but yeah, you'll have to wait because communication takes place. It's going to take around half a second. And turn on 9. 9 is on, 9 is off, and 8 is off again. Right, so this is it. Right, and next video I'll be showing you how to send the response. Now what we are doing here, I repeat here, we are grabbing it and we are printing it to serial. Whatever input we are taking from the browser, we are printing it simply to serial monitor. And what are we doing in Arduino? In Arduino, what are we doing? We are grabbing, in Arduino, what are we doing is we are taking whatever serial port 2 and 3 is giving us, because our RX and TX of ESP is already connected to pin number 2 and pin number 3 of Arduino. So now whatever we are reading, we're converting that to string and we are doing digital write LED pin, right, and toggling as that of opposite. Now we have to send the response back. It's not easy to print that response. Now we have to send response from here. Now we are only reading from ESP8266. We are not writing to it as of now, because we have done something very special and very different from other classes. Now the next class is going to be how to send the response back and show a different platform here, which one is on and which one is off. And we'll be having some LEDs and we'll be having some actual lamps instead of these programs, so that we develop a very nice user interface to control our home. And this is the most secure way, and there is no lag at all. And you, even if you use it as an access point, still you are not going to get any lag. Until then, please practice it hard. You are having Sunday, the day is completely off. Now practice it hard and close it down till tomorrow evening. And for that, I wish you all the best, and do practice very hard. Let me know down in the comment section if you require any kind of help or if you want anything else, or you can comment me or you can message me directly. Right, do practice very hard and wish you all the best.